Ladies and gentlemen, welcome to another episode of Science Without Consensus, exclusively on Rumble, Saturday, 8 p.m. Mountain Time. I'm your host, Diamond, from the Oppenheimer Ranch Project, and joining me today, as usual, is my lovely co-host and partner, Leah Shaper.
Hello.
Welcome to the program. We got a banger today. We're going to be talking about a topic that is in the news, and everyone is talking about a million-year-old skull reconstruction and how it may rewrite archaeological history, human history specifically. It may push humans back over twice as old as we think we are, which is 300 to 350 is the consensus, 300 to 350,000 years old for Homo sapiens, but this may push us back a million years.
Possibly, yeah.
Absolutely mind-blowing. We'll also talk about some more archaeological discoveries coming out about ancient mummies that were around during the African humid period. We've talked about this on the show. This is a time when the Sahara Desert was a lush savanna with rivers and lakes and probably a massive civilization. What's weird is that these mummies, we don't share any DNA with them. And they're not that old. They only go back around 14,000 years. Also, more discoveries at Göbekli Tepe. For all those people, you know, all those big stars that claim that they're not doing any excavation at Göbekli Tepe or in the region. They're just liars. That's not what's happening. They're excavating in almost all of those sites. And they just found another human figurine, another human figure statue. This brings three very prominent statues, and we'll look at them all. Anything you want to say before we jump into the show?
No, let's just jump in.
All right, let's dive on in. I just asked Grok to make this, and Leah hates it.
I don't like the font.
There's the show, folks.
It looks very cartoonish to me.
All right, we'll just get rid of it. A rare human statue has been unearthed at Göbekli Tepe, found between structures B and D with an intact head, a torso, but missing feet. The figure may illuminate Neolithic rituals. Excavation head coral notes. All right. This is where they found it, literally in the bottom of a wall. And this is a poorly built wall. It's a rubble wall with a statue in it. And there is the statue to the right after they took it out, I guess, and cleaned it up. But my initial thought, when you read the description of the statue, the feet are broken off, that it was a broken statue. So they just used it in the wall rather than, I mean, what else are you going to do with it?
You know, I looked at something else that might indicate this is not the particular statue that they were talking about, that this is a different statue. I'm not really sure, but the other statue.
Which one? The one that's pictured on the right?
The one that, both of these. There's another statue, and I don't have a link for the image handy, unfortunately. That's very similar to this one.
Yeah, so it looks Karahan Tepe, a year and a half ago, they unearthed this statue. And if you look at it from the profile here, it is the same as this guy with that weird hat on.
Yeah. Well, all I was going to say though about the legs is that the legs may not have. No, that's what's in the article of the text, that the legs were broken off. But the other statue sort of suggests that it wasn't made really with traditional legs in the first place. Like it was made sort of with a tapered bottom that would have allowed it to stand.
Yeah.
So,
and this statue, it looks like he's kneeling or has just short legs.
Right. So I'm not thinking that the lack of legs is an indication of anything. It's just simply how it was built. And they're not that tall either. They're not human size.
Yeah, they're like 3 or 4 feet.
Yeah.
Maybe smaller. The most famous of these statues in the Levant is Man.
Mm-hmm. With the same positioning of the arms. I think it's really worth noting this thing where the arms and the hands meet in front of the body, because we see this again and again and again. It's in all of these statues, but then we see it in other parts of the world too.
Right. The Moai have the same hand placement.
Right.
And the T-pillars, the ones that are anthropomorphic, have the same hand placement.
Right.
And this Man dates to 9,000 BC, 11,000 years ago, which is the date of all of these statues. So clearly Man has no legs either, that they're designing these statues with bases with truncated legs.
Right.
Yeah.
If I recall correctly, too, this V shape that looks like a neckline at the top, I recall seeing that repeatedly as well.
Well, you can kind of see if it's not his collarbone, there's a V right there.
Yeah.
It also looks like he's holding something.
Yeah, like a moon or something like that. But I do find it funny, though, that a lot of these articles, they say, "Oh, well, this statue opens up, it elucidates a lot about their religious beliefs." And I'm like, "No, it doesn't."
They
Like,
also
you
call
found
it
the statue in the bottom of a wall. Like, how does
right,
that
and
elucidate anything
they
about
also
your
refer to
spiritual
it as
belief?
rare, and I'm like, there's tons of statues from this site, and they're all similar.
Yeah.
How it's not rare; it makes it common. If you find 3 of similar statues at this time, they're not rare; it's common.
Yeah, and then
Think of how
the
many
other
statues we didn't find.
right. And then the other thing that I think that would support that idea that they're common is now there are people suggesting the fact that this statue was found at the bottom of a wall in that first picture you showed to that could potentially mean something like that made it somehow like an effigy or something like that. But to me, this really looks like just recycling rock. And perhaps, as you
Yes.
suggested, maybe it was broken, and it's like, oh, let's recycle it. It doesn't look like anything other than that to me. And if these were common, that would make even more sense.
Yeah,
They
and who
weren't
is this?
particularly special, and so you can reuse them as part of your wall.
Well, and like the Pueblo people out here, when they would break pots specifically on purpose if they were no longer of use. So
Yeah.
it's a common practice to break things. I mean, this goes back way in history. People would burn buildings after it was of no use and move on, things like that.
Mhm.
So it might have been just common practice to use, or maybe it's a ruler and he's no longer the ruler and they have no need for that statue anymore. They're making new statues.
Right.
Yeah.
But
But
also, I mean,
I
I think it's important to recognize too that like maybe we underestimate the role of quote unquote recycling in older cultures, right? Because this is like something that's new to our modern culture to actually recycle materials instead of just throwing them away. I mean, it makes sense, obviously, if you had got a piece of rock, like why not use it again?
and it's a very poor statue. There's way better bas relief carvings at Göbekli Tepe in these areas. So this is a pretty poor one. And maybe while they were making it, it didn't, it was getting better. They were in the process of using this, but something broke off and they couldn't continue. So they just put it in
Maybe.
a wall.
Well, also, this is heavily eroded. It's limestone, so that makes sense that it would be heavily eroded.
Yeah.
So
And this one from Karahan Tepe, it's pretty poor quality carving.
yeah, yeah.
And San Lerfa, man, again, it's pretty low end. Could be,
Well, you see a quite a range, like not so much at Göbekli Tepe, but like Karahan Tepe, for example. There's a pretty wide range of like skill levels of the bas relief. You see some stuff at Göbekli Tepe that's absolutely spectacular, and then everything at Karahan Tepe looks much more rough.
yeah.
You know,
Yeah.
so it's almost as if this is like a new technique that's being developed at the time in this area. Because Karahan Tepe and Göbekli Tepe are only separated by what, like a few hundred years?
They overlap.
Yeah.
Göbekli Tepe
Okay.
spans, yeah, all these sites overlap
Right.
in one way or another.
Right.
And Karahan Tepe might even be older.
I thought it was.
Yeah.
Yeah.
Well, they're guessing, I think.
Sure. Sure.
It's all guesses.
Yeah.
But what's clear here is that 12,000 years ago, we have an advanced Stone Age culture, a very high society, doing very complex things that we, right now, even after years of excavation, we have no idea what's going on at Göbekli Tepe or any of these sites in the Levant.
Right. And yet, it's still these sites are always presented to represent a culture that was just becoming sedentary or agricultural, and it's like That doesn't make any sense. People have clearly devoted huge amounts of their time and effort into building these places and doing all of this bas-relief sculpture and arranging these stones into some fashion that we don't even know what that is supposed to represent yet. And so it doesn't make sense to me that these are people just transitioning out of being migratory peoples. That seems really dumb to
No,
say
you
that.
would need huge groups of people to pull this off, which means they have to be continuously working, which means you have a constant supply of food and anything you need. So this is
And you need to be there like all the time
yeah,
to
it's a
do this stuff.
well-established society. They didn't just figure this out.
Yeah.
And we're going to get into that. So we're going to get into the idea that the human race may go back 1 million years and it flourishes. So this is like the first, right here at this site is the first archaeological assemblage of artifacts that we can look at to say that this is a very sophisticated society, and it dates all the way back to the Younger Dryas.
Mm-hmm.
There's nothing we have really before that except some cave art that shows high sophistication. Those go back to 40,000+ years. And we also have the Lion Man carving, which is also 40,000+ years old.
Mm-hmm.
So clearly, whatever this high culture was goes back 40,000 years at least, which is 28,000 years older than these sites. And what I think I can show is that there have been at least maybe 10 or 15 times in human history, we call them interglacials, that we may have flourished like this.
Sure.
Time and time again, and it gets erased. That's why we don't have any information. Well, we do have like some rocks in Peru, right? That we have no idea what they are.
Well, that's the problem, right? We have some absolutely spectacular, let's say, megalithic sites that can be really hard to date.
Yeah.
There's an official story, but Sacsayhuaman, for example, actually, I don't even know what the official story there is, but the official story would be something like, oh, the Incas built that. But that's clearly not the case, because what the Incas did later is much less sophisticated than what was done before them that they built upon. So
yeah,
I think that's the really big problem that we have right now, is that we don't have dating that makes sense for a lot of sites that are probably far more ancient than this current epoch of quote unquote advanced human civilization. There's probably been repeated episodes, like you said, of advanced human civilization for which we have limited evidence. There is it would seem that there is evidence. We just don't know where it fits into the whole picture because it's not dated.
Right.
Or not dated accurately.
It gets lumped together as megalithic, the megalithic culture. But the megalithic society that built Göbekli Tepe and those T-pillars and those megaliths, that technology has nothing to do with the technology at Sacsayhuaman.
Right.
That's a completely different culture with a completely different technology.
Right.
That probably predates Göbekli Tepe by quite a significant amount, in my opinion.
Right.
I think that may be left over from the Eemian, which is mind-blowing because that would place it 120,000 years ago when those structures were built.
Remind me, oh my gosh, now I can't remember his name. The geologist that kind of redated the Sphinx. I'm spacing on his name right now.
Robert Schoch.
Thank you, Robert Schoch. Remind me what his estimate of the Sphinx date is.
His estimate conservatively is that it dates back to the African humid period, which we're going to get to. So that could be as old as 14,000 to 5,000. So older than they suggest.
Right. But not
because that's the only time you can get that much water to create that erosion.
Right. Okay. Right.
And it has to be present during the humid period for a long period of time to create the erosion. So he puts it 7,000 to 10,005.
So, I mean, that's the thing. It's like even that concept, despite the physical evidence for it, there's so much pushback against it. So like, how in the world are we going to have a scientific conversation about, the age of, let's say, Sacsayhuaman or something like that, when we can't even push back the date of the Sphinx based on physical evidence,
Yeah, we have to develop a technique to date a rock when it was carved, and it's just like there is nothing you can think of to figure that out.
Right.
So it's just it's anyone's guess.
Well, obviously you can do some work based on, the amount of erosion and the type of rock it is.
Yeah, but that type of rock takes tens of thousands of years to erode, so you get a huge window of
Right.
how old it could be.
Right. Right.
So that's interesting. So let's dive into the subject, shall we?
Mhm.
We'll first talk about this article from Vice. Newly discovered ancient mummies don't share DNA with modern humans. Now, these are the people that would have carved the Sphinx.
Mhm.
And even it's not hard to push the Sphinx back to 10,500 years ago because we knew there were advanced rock artisans nearby at
Yes.
Göbekli Tepe.
Right.
So clearly this could be accomplished in this region.
I just want to mention one thing, also just for our audience. These are not like human created mummies. These people were not mummified by humans. They were mummified by natural means.
Yeah. So between 14,800 and 5,500 years ago, during the African humid period, what we now call the Sahara was a lush savanna. It had lakes, wetlands, trees, and a group of mysterious humans who don't share DNA with any modern humans. That's interesting.
Mm-hmm.
The researchers dug deep into the ancient DNA and found that these women, now there were 2 mummified women found at Takakori rock shelter. So the reason they're mummified is because they're inside of a rock shelter. The conditions are perfect. It's probably low humidity. They don't get a chance to rot, and they dry up and they become perfectly mummified. This happens all the time.
Right. And this is a hard part of the world to get remains from, specifically for the reasons that it is humid. So this was a lucky find.
Okay, so they found these 2 mummified women in the shelter, and they dated them to around 7,000 years old. They dug deep into their ancient DNA and found that the women weren't genetically sub-Saharan at all. They belonged to a previously unknown North African lineage that broke off from sub-Saharan populations way before anyone was naming continents. Now, what do you think about this find?
I'm a little bit more perturbed about the pictures they use in this because the pictures are just generic pictures. They have nothing.
It's
They're not of
Vice.
the actual remains. And they're using pictures that show human-induced mummification, not it's irritating.
Yeah.
I mean, this is
It's Vice.
Yeah, right. These 2 women, they are related to another North African population. But then they also have differences from those populations. I mean, it's fascinating, right? Because you and I have talked about this a lot, especially recently, where, there's this idea that, all evolution is kind of like this linear progression. We have a common ancestors or whatever. But what seems to happen is like there's almost like a breathing that's happening. We have species that sort of diverge and then somewhere and create all these different varieties, and then somewhere along the way we come back together again.
Yeah.
And this clearly is like some branching event that occurred at some point, which is why we don't really share much DNA or any DNA. We must share some. I don't really understand how they can say that we don't share any. But it is kind of fascinating. And these people do have some Neanderthal DNA as well.
Right, because if we didn't share any DNA, they wouldn't be humans.
Right. Right.
So what's where they're confusing, and I think everyone is, and we talk about it all the time, is that we don't know anything about hominid species. The hominid species that we are told exist, like Denisovan and Neanderthalensis and Homo sapien, they may be incorrect in the sense that they may just be morphological differences. And we discuss how we have morphological differences on Earth today. Like if you were to dig up a Samoan graveyard and compare it to a North Korean graveyard, people would say they're 2 different species. Yeah. And we're going to dive deeper into that because we don't really know anything about the human species. And what we're finding is that we keep getting older and older. Think about it. 50 years ago, they said that modern humans dated back 30,000 years. That's 50 years ago. And then we went to 115. And then we got another cave and we went to 150. Then we found some humans in another cave and we went to 300. And now what we're finding, and it's not new. This is not new, what we're going to talk about, this new reconstruction of this. This skull has been around since 1990.
Yeah, I learned that along the way.
Yeah, and they said it was a different species, and they just said that's what they do. They find something they don't know. It's a different species of hominid, and they classified it as Homo longi, or Dragon Man.
Right.
And so they've known about this for 25 years. But what they didn't have is AI in this software that can reconstruct the skull. And when it did, their mind was blown. And so this is more morphological data that they're getting. That's all it is.
Yeah.
Right?
Right.
And so there is a morphological similarity to modern humans in this skull that goes back 750, 800,000 years that we're going to get into. And what it's revealing is that, which is interesting, that the entire span of the Ice Age is when humans may have existed. And I think,
meaning Homo sapiens.
Yeah. And I think that the Ice Age may have something to do with our existence.
Yeah.
That's interesting. So anything you want to talk about these mummies before we jump into that morphological paper?
Well, yeah, I got a bunch of things to say about, genetics versus morphological, but this will come in somewhere along the way. So,
but nothing about the African mummies.
No, not particularly, but I did want to mention one thing. This reminded me of one of the big things that kind of destroyed the out of Africa hypothesis was the discovery that there's some kind of ghost DNA in, I believe it's sub-Saharan populations that the rest of us don't have.
Yes.
Which destroys that theory. But this is another reminder that it's not, again, this is like evolution is not linear. We have common ancestors. I think it only makes sense that
we have to
have common ancestors somewhere along the way, right? But we also diverge at many points and in many places. The evolution is so complex in that respect that we keep trying to stamp this like linear progression on top of it, and it will never work. And I don't know that we'll ever actually untangle all of this simply because of what I was saying earlier about this sort of expansion and contraction that seems to happen amongst hominids, that it makes it very hard to untangle exactly how all of this has happened over time. I mean, I think we can get some senses of it, but this is just another reminder that this idea that we all come from the same place is completely preposterous and it doesn't make sense.
Well, and they also allude to it here in this article that the reason these people, this group of humans, may not share DNA with us right now is that due to isolation.
Right.
And that's exactly what you're talking about. So there's times when the population of humans on Earth is low and we're isolated. And then there's times when we meet again and flourish. And I believe those times are separated by 100,000 years. And we'll get to that by the end of the show when we show you the ice core data. And that would give, the span of humans, if we go back 1 million, there would be 15 times where we would be isolated. And that's when we would get these morphological differences.
Well, the thing I did find interesting, though, about this particular isolation, there's clearly an genetic isolation here.
Yeah.
But what I found interesting about that is that this population was existing in the African human period where the Sahara would have been highly livable and not cold. And yet this particular group of hominids they would have to, aren't these don't these have to be Homo sapiens?
Yes.
At this era? But
yet
they don't share DNA with modern humans.
Only Homo sapiens for the last 30,000 years. That's the oldest Neanderthal, or the youngest Neanderthal we found, 31,000 years old. So
Yeah.
everything past that's Homo sapien.
This title is terrible.
Yeah.
Clearly we do share some DNA. That doesn't make any sense.
Yeah, they're Homo sapiens.
Yeah. Because well, anyway, but
let's talk about the million-year-old skull
Yeah.
reconstruction that hints at a new chapter in human evolution.
Mm.
What they did was they digitally reconstructed a million-year-old humanoid skull found in China, and they claim the skull challenges the established timeline of human evolution.
Mhm.
Genetic testing could help confirm the theory, but the researchers say they can't glean genetic information from the fossil, which is unfortunate. Here's the paper. In anthropology, the phylogenetic position of the Unishan cranium elucidates the origin of Homo longi and the Denisovans. So that's a mouthful there. It goes on in the abstract to say diverse forms of Homo coexisted during the Middle Pleistocene. Whether these fossil humans represent different species or clades is debated. And when I read that, I was like, yes!
Well, I mean, don't get too excited, because there is some other evidence presented that these are separate clades, but
well, what is a clade?
Well, that's the other problem here, right? Is like, well, what exactly does that mean for human evolution, and what does it mean in terms of our, let's say, interbreeding potential? And it doesn't mean that we're separate species. It's all a clade is a branch on a phylogenetic tree.
Yes,
So,
and so Asians would get a branch, right? And Eskimos have a branch, and Filipinos have a branch.
Well, not necessarily. So this is something I wanted to get into. So let me do it now. Okay, so this was something I was reading about, and this was like about viruses, but I think you can extrapolate from this. There was this sort of misnomer that was occurring during all of the COVID insanity, with the media calling, certain changes in viruses, different varieties, or variations. And like, in reality, like a variation would be more like enough of a genetic difference, a difference in the genotype. So just the actual genetic data, the bases that are used, versus a phenotype, which is like when the genotype is actually expressing itself. That's the morphology part, essentially, or its function or its behavior. And so, like, you don't technically get a different variety until you start seeing very significant differences in the manifestation of that thing, right? Not all genes express, not all genes turn into things that are physical differences or behavioral differences or whatever. So, I mean, it's still, the dividing line is still kind of fuzzy, but it's not until you get those significant differences that you can even call something a variety. But a variety is like, I mean, you can think of certain species of plant, and then within that species, there's a bunch of varieties where the plants actually look different. The varieties of plants look different to each other within the same species. So, like, you could say that, like, races in hominids right now are just varieties. And consider also that the statistical difference in genetic information, let's say between Neanderthals and Homo sapiens, is only 0.2%. So, like, I mean, we're calling, or science is calling Neanderthals and Homo sapiens different species, which is, I think, debatable. But just
it's
that,
not true, because we interbred. It just cannot be true.
well, unless it happens to be that they are two different species with exactly the same number of chromosomes, and that's the reason they can interbreed.
Yeah. Well,
Like, you could make that argument.
Here's what's interesting about all this and the new study is that we've had information for 15 years that suggests that humans go back about 1 million years.
Mhm.
So we've actually sequenced, let me go here. We actually sequenced a complete Neanderthal genome in 2010. Did you know that?
No, I didn't know that.
Yeah. And then based on the sequencing, they determined that humans and Neanderthals go back at least 800,000 years to a common ancestor, which if there's, see that this is when it gets confusing. Like we sprung out of some other species, that makes no sense whatsoever.
Well, here's the problem. We're trying to take a natural process that has a great deal of fluidity. And I think like trying to say illustrate the difference between a variety and a species or a clade in an evolutionary an evolutionary branch that's called a clade because you have these organisms that are very similar, genetically similar to each other. But like we're trying to put a stamp and a structure on top of a process that is extremely fluid. Like, it's like, where is the dividing line between any of these things? And honestly, I don't think that we've defined those well at all. And it's just a human construction, a mental construction on top of a natural process. So I think that's the problem here. You know, we're making all of these definitions and saying, oh, therefore these things must be different species. But in reality, the definition of what a different species is highly debatable and maybe not even in any way relevant to evolution of anything on human Earth, except for the ability to interbreed. Like, I don't think any of these definitions even really matter at the end of the day.
Yes, agreed. Let's talk about the information they had all the way back in 2010. Now, they used several different Neanderthal skeletons to do this genomic study, and from all over as far spread apart as possible. You know, they're not three people from the same cave, let's say. Mm-hmm. Yeah. So where is it? This is what the interesting, and you just elucidated to this. To understand the genomic difference between present-day humans and Neanderthals, the researchers compared subtle differences in the Neanderthal genome to the genomes found in DNA from 5 people, as well as to chimpanzee DNA. The analysis of the genetic variation showed that Neanderthal DNA is 99.7% identical to modern-day humans. Which, in my opinion, would make them modern-day humans, especially if we can breed with them. And this is all the way back in 2010, they knew that.
Yeah.
So present-day humans' DNA is 98.8% identical to chimpanzees. So that you can see 2 different species, obviously over 1% difference in DNA. That makes sense to me.
Right.
But as close as Neanderthals are, that doesn't make sense to me. But what's interesting, they concluded back then that we go back to a common ancestor 800,000 years ago. Now, what I think that that actually means is that humans and Neanderthals, which are the same species, they're just calling them different things, has been interbreeding for 800,000 years ago. That's all that means.
Well, and there's sort of I think it's happening in 2 directions. I don't think it's just that, you know, we diverged, but obviously we're still capable of interbreeding, but we also continued interbreeding much later, much further down the line.
Yeah.
You know, like we may have been interbreeding 60,000 years ago.
Or 600,000 years ago.
Right. But I think we were probably doing both.
Yeah.
Right. I mean, it's still really interesting because like, okay, as far as like morphological differences go, and I don't know this really well, but just this is what I've gleaned just from things that we've read and discussed and whatever. But you know, there are, let's say, in the shape of skulls, of like Homo sapiens versus, I don't know, Homo floresiensis. You know, there are going to be very significant morphological differences between those skulls. You know, and like, let's say, you know, some species will have, well, I'm just going to call them species for the ease of use, but will have, you know, like a really prominent brow that like Homo sapiens just don't have. But again, all of that stuff, it's still kind of on a continuum. and
Yeah.
potentially not that important, especially if we have the same number of chromosomes and we can actually interbreed. But also, like, as far as chromosomes go, like, just having the same number of chromosomes doesn't completely do it, because there are other organisms with 46 chromosomes, like Homo sapiens, which includes like a species of antelope and an olive tree. Obviously, we're not going to be interbreeding with those.
Well, have we tried?
Well, well, that's a good question. I kind of get the feeling it's not going to work, but
An antelope tree sounds interesting.
um, where was I going with this? So what I was trying to say though is like I think if you look at the skull of like an Asian person and a Caucasian person, you're not going to find the very significant morphological differences there that you would between, let's say, Homo floresiensis and Homo sapiens. So, but again, is this just all a function of the degree of difference?
Yeah. So here's the brow ridge you're talking about. There is a pronounced brow ridge on the skull that they reconstructed.
Mm-hmm.
It's very similar to other skulls that they've determined to be Homo longi.
Yeah.
But these are all slight morphological differences between this dragon man, Homo longi, and Denisovan and Neanderthalensis. They all have prominent brow ridges that are either bigger or smaller. And here's the problem. There's almost no fossil record of humans back at this time. There's just none.
Right.
And there's a good reason for that. Did you come across anything?
In what respect?
Well, I found this paper, Genomic Inference of a Severe Human Bottleneck During the Early Middle Pleistocene Transition. It says results showed that human ancestors went through a severe population bottleneck with just 1,280 breeding individuals between 930,000 and 813,000 years ago.
Didn't we talk about this on a show before?
Yeah, it's an old paper. No, it's a 2023 September paper.
Yeah, like in the last couple of years, we talked about this.
The bottleneck lasted for 117,000 years and brought human ancestors close to extinction. Well, it also probably brought them close together, and we were interbreeding.
Well, that's just it, right? Like, it's like prior to this bottleneck, clearly we had a lot of hominids.
Yeah.
Right. Like, this even lines up well with the divergence that's discussed in this paper about the Jungian cranium, right? So, like, just as an example, one of the things that they conclude from this is that, okay, Homo sapien, Homo longus, and Longus, Neanderthal, and Denisovan were like separate clades, right? And Homo sapien falls in here as well.
Yeah.
So the divergence, let's say roughly about 1 million years ago, but the Longi clade would have existed for about 1.2 million years. The sapien clade would be 1.02 million years. And the divergence between those two was 1.32 million years ago. And then, I don't know, I might be misreading part of this. Anyway, I thought Neanderthal was in here. But, we clearly had what we're calling different hominids all existing at the same time. And then if we suddenly get into this bottleneck, what is this, 930,000 years ago? Well, that's all of those different hominids like coming together essentially to create what we're now calling, or what we're now considering, Homo sapiens.
Yep. So interbreeding for 117,000 years from the remaining hominids, just 1,280 breeding pairs resulted in modern humans. That's it.
Right.
And we've been around for 1 million years. Let that sink in. 1 million. Well, there may have been other clades of lesser intelligence or lesser skills or greater skills.
Sure.
And for the next 1 million years, we make our way to where we are today here in this podcast on Rumble.
Well, and then it's going to be much older than that, right? Because this is suggesting that the Neanderthals...
What's going to be older?
Homo sapiens or modern humans, right? Like Homo sapiens and Neanderthals would have diverged 1.38 million years ago, which means that, I mean, we were still existing before that. It's just that we had a genetic divergence that we're now calling different species, but that's not necessarily true at all. And this coming back together because of the genetic bottleneck makes that even more clear that we were never separate species. We might have had very significant morphological differences in our teeth and our skulls,
Yeah.
but that's just the nature of genetics and evolution.
And teeth studies show that Neanderthalensis, Homo sapien, Denisovan may all be the same species.
Yeah.
Now, here's what's interesting. Here's the Epica data. This is ice core data that goes back 800,000. They just found some new ice that's older than this, so we're going to extend this next year
cool.
all the way back to 1.2 million, I think. So we'll get a couple more interstadials in there.
Yeah.
But if you look on the far right of this graph, that's where we are today at 0.
Mm-hmm.
And this little blip from the rise up to the point is, according to archaeology, all of modern humanity. That's when everything historically happened to humans, meaning we learned how to farm, we learned how to build structures, and now here we are today with advanced technology. It all happened in just 12,000 years. And prior to that, we were just dumb cavemen for 1 million years, apparently. Now, the problem with that story is that I don't believe it. And you shouldn't believe it either. Because here's another way to look at it. This goes back 900,000 with 0. It's the opposite way. So 0's on the left on this graph. And that little green strip on the left side is all of modern humanity. The problem is we also have other very long green strips here. These are all times that are interstadials during the Ice Age when civilizations can be built and destroyed. And if we've been around this entire time, I believe there's 10 chances for us to create civilization and then destroy it 10 times. And right in the middle here, look at this extended period where it's green almost continuously for over 100,000 years, from 620,000 years ago to 470,000 years ago. I mean, there are opportunities, to say the least, that we could have at least 10 civilizations have come and gone in humans' archaeological history.
Right.
Does that make sense?
Yeah, I mean, that's the thing is, like, even on just a purely statistical basis, the idea that, and I'm going to say humans in the broadest sense, did not develop high civilizations in any of these interstadial periods seems highly unlikely. And it's kind of stupid to think about it that way. I mean, I kind of equate it with, like, the idea that we're the only intelligent life in the universe. I mean, space is so wildly vast, like, that it is highly statistically unlikely that that is the case. And this kind of rings similarly to me, except that the statistics would point, well, either way, the statistics point quite strongly to the idea that why would the current interstadial be the only period where we developed technology? Like, that doesn't make any sense.
Well, and we have evidence that it's not true.
Well,
we've talked about the Colombo structure.
Yeah.
This is the oldest wooden structure ever discovered, and it's recently discovered in Zambia. Did I say it right? Yeah. I think I said Zamibia on the show.
Well, right, because we always get stuck with Namibia or Zimbabwe. I think we were getting caught in between the two of those.
So this is found in Zambia. It dates to 476,000 years ago.
Right.
That's old. And guess what's happening 476,000 years ago?
Oh, I bet it's a warm period.
It is a interstadial right here.
Yeah. Yes.
This whole long interstadial, and 476,000 falls right in the middle of it. So it would have been warm for tens of thousands of years. Humanity would have been flourishing. This is apparently a dock or something where they're fishing on the edge of a lake. And so humans are doing stuff 476,000 years ago. during an interstadial.
Yeah.
And so there is evidence that humans have been around for quite some time, and we are just scratching the surface. So not only do we have the bottleneck that happens, that lasts for 100,000 years, very little fossil coverage during that time because there's not many people.
Mm-hmm.
There's just not any fossil coverage for the last million years because human bones are hard to come by. They have to be perfectly preserved, like in the cave with the mummified women.
Yeah. Yeah.
Typically, when a person dies in a cave, things go in and eat it. And then the
Yeah, I mean,
bones get dispersed.
we probably only have like, 0.001% of all of the potential data to inform the evolution of humans, right?
Right.
Like just based on fossils. And we'll never have it. We'll never have anything more than like probably like 1%. I mean, we're trying to put together a whole picture and a theory and understanding of our evolution based on just the tiniest smidge of data, simply because things decompose and they break down. Like the Zambia wooden structure is a great example. I mean, we're so lucky to have that. And the only reason it still exists is because it was like underwater in this hypoxic environment that just hasn't changed in all of that time. And that was extraordinarily lucky. And then, on a philosophical level, and I've said this again and again and again on this show, but I think it bears repeating, this repeating cycle of ice ages and interstadials, and what we speculate that's done for the evolution of humans is to me, the universe is scalar, right? Like that there's patterns that repeat on every level of existence. And this is part of one of those. This is part of a cyclical cycle where, we have a civilization that grows and then it collapses due to, let's just call it natural catastrophe. Like whatever informs this ice age cycle, whatever that is, and the catastrophes that go with it that contribute to the loss of humans and other animals on Earth, like clearly this has been repeating for a long time. And to me, this very much reflects the idea of the Yuga cycle, right? Our civilization sort of advances and increases up to the golden age, and then it starts decreasing, and it's somewhere along the way we hit these natural catastrophes and we lose everything. And then it also, to me, reflects the idea of reincarnation, that we continue to reincarnate. We each pick the lives that we're going to incarnate into next to learn something specific. And when we die, after we die, we have to forget. When we reincarnate again, we have to forget the previous life, because if we didn't forget, there would be like no way to learn anything new. It was like we'd have too much information. And to me, it's all a reflection of the same repeating kind of cycle. And that shows up everywhere. It shows up in the natural world. It shows up in the spiritual world. I mean, of course, I have beliefs that not everybody shares in that respect, but to me, it all goes together. And it's precisely because the universe is scalar and that the patterns repeat at every level.
Yeah, so this electrochemical bag of water is actually useless, and it's whatever the soul is controlling this electrochemical bag of water that's important.
Right. Well, it's not useless. I mean, there's a reason.
Well, it can pick stuff up and eat food, but
well, I mean, I'm just suggesting it's not useless in the sense that there's a purpose for us to incarnate into these bodies or into whatever.
Great segue to the next topic.
Oh yeah, this is a great
We
topic.
emit a visible light that vanishes when we die, says surprising study. Life truly is radiant, according to an experiment conducted by researchers from the University of Calgary and the National Research Council of Canada. An extraordinary experiment on mice and leaves from two different plant species has uncovered direct physical evidence of an eerie bio-photon phenomenon ceasing on death, suggesting all living things, including humans, could literally glow with health until we do not. And here is the paper, Ultra Weak Photon Emission, a brief review. Now, we've known for a long time that when the human body dies, right across that threshold, if you had them on a scale that was very accurate, something leaves the body and it becomes lighter at the time of death.
Mm.
And it's unexplainable. This may have something to do with it.
Well,
but what do you think about this idea that all life has this biophoton?
so okay, look, I actually don't find this particular discovery, I don't find it surprising in the least. And the reason I say that is because on a very basic chemical level, and this is mentioned at least in the article, like one of the contributing factors to this would be something like reactive oxygen species. So a reactive oxygen species has unpaired electrons. That's what makes it reactive, and that's what it interacts with other molecules, and essentially in the biological world, it then causes damage. But when two atoms interact, this is one of the things that happens. Like you'll have electrons that get, I'm not explaining this well, but electrons that will get paired, and then that causes a release of like a photon. There's an actual energy loss that occurs, and it usually occurs in the form of a photon. Like this, a similar thing will happen when you have an electron that will like drop down a layer. It releases a photon, because it's literally like that energy that it was holding on to was allowing it to stay in this outer orbital shell. And once it drops down, it doesn't need that energy anymore. And that's how it gets released in this discrete energy packet, which is a photon, which is light. So this is not surprising to me at all. I think the piece that we're missing, maybe, so like just on like a purely chemical level, it's not even a biophoton. There's no difference between a biophoton and a photon. It's just a photon being released within the context of a biological organism. That's all it is. And in fact, this paper that you have up right now makes that distinction, that there's nothing specific about a biophoton that makes it any different than any other photon. But maybe the piece that we're missing here is, and maybe this is part of like why we have a hard time understanding the nature of energy at that level, right? Like why quantum mechanics is so bizarre is perhaps to me, it seems like there's a connection between physical energy and spiritual energy that we don't understand right now.
Yeah.
I think if we were higher up in the Yuga cycle, we would understand what that relationship is, but we're not there right now. And, there might be like a genius here or there that might be able to put that together and figure out what that relationship is, and then that would maybe explain like what you said. When a body dies with an extraordinarily accurate scale, we would see that the body actually weighs less, which again may just be a function of the energy lost, right? Because energy and mass are on a continuum.
The opposite of that is conception. And I've seen videos that upon conception, when the sperm enters the egg, it releases a light.
Yeah.
So that's the biophoton.
Right. Right.
So
but
the light is released at conception and at death.
Yeah.
Both directions.
Right. Well,
let there be light.
Consider that you're dealing with biochemical reactions either way, right? The only difference with death is that obviously all of that activity is going to cease. There will be no, well, no, that's not entirely true, because decomposition will be part of the equation, but you don't have, so in the paper, which is not this paper, but the experiment that they did with mice, and they were able to visualize the photon emission in living mice, and then they looked at the mice when they're dead, and there's almost no photon emission at that point. It's just a function of the metabolic processes have stopped.
There we go.
And it's the metabolic processes that are releasing the photons, right? Yeah.
There's the live mice on top, the dead mice on bottom.
I couldn't help but wonder, like, okay, if you look at M3, the third mouse from the left with that red area, and then in death, it's green still, like what is happening there? Is that an organ doing something specific? Does this mouse have cancer that's causing like a different metabolic situation right there or whatever? I thought that was interesting.
And we can also look at the leaves.
Yeah.
There we have it.
Well, and specifically too, they tended to note I think on the leaves, the highest photon emission was in areas where the leaves were purposely injured. So that speaks again to the idea of this may largely be caused by reactive oxygen species interacting with other molecules in the body or the leaf.
Great show. Anything you want to finish up on?
I think I
Or
said
circle
everything I wanted
back?
to
I
say.
love that. You want to circle back?
Whose line was that? Was that a
Oh, I
Kamala
forget.
Harris line?
Jen Psaki.
Oh, Jen Psaki. Oh my God.
All right, guys. Thanks for watching. Share this video with like-minded people or people you just want to piss off or people with scientific minds that like to dig a little deeper. It's a great show, and we will see you tonight, 8 p.m. on Rumble, and then we'll replay this on Wednesday over at YouTube. Bye now.
Bye.